My name is Rathish Das. I am from Computer Science Department. I am advised by Professor Rathish. So today we are going to talk our work on databases and discrete resource time trade-off problem with resource reuse method. So I work in the parallel computation, and in parallel computation, one of the major objectives is that without compromising correctness, you want to run the program as fast as possible. And towards that objective, the most problematic scenario is that the data races. So consider this scenario that there is one memory address which is here called M, and there are 8 instructions, 1 through 8. They are all trying to access, and maybe one of them is trying to write at it, at least one. So if that is the case, that's a race, and in that scenario, we have to do all the 8 instructions one by one, serially, and that reduce the parallelism, right? And so what we can do, this work basically try to solve or try to increase the parallelism by adding extra resource or adding extra space, which sometimes we call as reducers. So this memory space same M, and these are the extra spaces colored as yellow. And using those extra space, it can be done much faster. So that effectively the running time is the longest chain in this tree, which is 1, 2, 3. Instead of 8, it is now 3, right? So this is the motivation that why using extra space can increase parallelism without compromising the correctness. Now let's go to the problem formulation. And in parallel computation, we generally formulate the computation as a directed acyclic graph. For example, you can model this as a computation where these are tasks. For example, these tasks takes 10 units of time, and using extra space, you can reduce the time it takes because those are maybe serial like that. So the objective is this, that how, if I give you some, we come up with 2 problem formulation. First is minimize make explain problem, which as if I give you a extra resource budget such as space, what is the optimum resource usage such that the 30 seconds left. The whole problem, the next one is minimized, and the other problem is we want to minimize the total resource usage.
So for the next time minimization problem, so we have some extra resource, and we have to flow those extra resources through the edges here, such that the overall make span is minimized. So for that, we have these results. We have a lot of trade-off functions like arbitrary, non-increasing, recursive, and multivariate, and we have approximation algorithms and hardness proofs for that. So if you want to check out more, you can see that.